Hey guys, this is Mr. Sal. This is just a quick look at some rational equations. So we're looking now at polynomials and fractions, but now it's an equation. So I'll have to be solving for x. So thanks for watching. Don't forget to like and subscribe and comment below. Just as a basis though, this is rational equations. And we're looking at fractions, but they equal something else, which, since they're fractions, makes it more of a proportion thing. Now, in my other classes, we talk about several different methods for solving these. In this class, we don't really necessarily use fish method, even though we can. Fishy method. Some people call it bow tie method.
Oh, okay.
You don't have to like either of them.
Fun names.
Yeah, it's pretty cool. I like to draw the fish anyways. But in this class, we'll be using, for the most part, cross multiplication, which is actually what most of my 980 students prefer anyways. But you can kind of see from these examples, especially with the subtraction like you see on this one right here, before we make that one fraction, which is what we do need, we would need common denominators from that. Now the nice thing is if you get common denominators for the whole fraction, right? Like if you had 3/4 plus 2x fourths equals 9/4. I don't know what that answer is, but you could rewrite this without any of the denominators. 3 plus 2x equals 9 and solve it from there. Okay. So if we can do that, in fact, I think we'll look at some of those like that, but otherwise we'll just be solving these like we would proportions. Let me see what this is. Solving equations containing rational expressions. Clear the equation of fractions by multiplying both sides of the equation by the lowest common denominator. It just needs to be common denominator, really, in all rational expressions, just like we saw on that last problem, right? Once we have common denominators, whether it's just a number or some kind of expression, then we get to write it without any denominators, and then we solve as usual, right? Now, if you're looking at some kind of polynomial, then you'd be looking to make it equal to 0, which allows you to factor it and then solve for your zeros. And then, of course, step 3, which gets skipped often, check your answers, all right? Or you can multiply both sides of the equation by the lowest common denominator of all rational expressions in the equation, and then simplify both sides. I would call that cross multiplication. At least that's the way that I read it. Determine whether it's linear, quadratic, which is just polynomial, or a higher degree and solve accordingly. Okay. Maybe use substitution. Not that we see a lot of that. But step 4, once again, often gets skipped, which in equations makes it pretty easy to check because your calculator will do that work for you. It's like this one. We could make an attempt to try to make these denominators the same, but well, you'd end up with some kind of polynomial anyways, which actually wouldn't be too bad because you get to eliminate the denominators after that, no matter what, okay? One thing we should acknowledge, though, is the denominators, right? What values of x would make the denominator undefined? Well, that means that if I had x plus 4, if that were to equal 0, that would be bad, so we don't want it to equal 0, which means we don't want x to be negative 4. I'm showing this because eventually, I don't think it's in this problem, but eventually we may see some that have an answer which is not in the domain, which means it's not an answer because it's not in the domain, all right? Or if x minus 10 equals 0, that would be bad, so we don't want that, and that means x cannot be 10. Okay, so if an answer comes out to be negative 4 or 10, we would just say that is not part of it. If it was the only solution, we would say that there's no solution for that. This one, we're fortunate enough to find a solution, and to get that, we're going to use that cross multiplication stuff. So there's one of the cross parts for that. So I'm going to take the 8 numerator and multiply it by the other denominator, x minus 10. And this should equal the other cross, which is x plus 4. And then we're going to multiply that by 6. Some good old-fashioned cross multiplication right there. Now to solve this, we'll distribute the 8. So we got 8x minus 80. And this should equal the 6 distributed, 6x plus 24. I forgot my 0 there, didn't I? So cross multiplication is how essentially we would have gotten rid of the denominators. Because on this side on the left, right, we would have had to multiply that by x minus 10, but as a factor of 1, x minus 10 like this, and then we would have distributed the 8, right? And on the other side, we had the x minus 10, so we'd have to multiply that by x plus 4, but as a factor of 1. So cross multiplication is how we get common denominators anyway, and then see those canceled out to give us what we had in this line right here. Well, now we're ready to solve. I'm going to put my x's on the left, not that it matters where we put them. So I'm going to subtract 6x from both sides, and I'm going to add 80 to both sides. So what do I end up with? I got 2x equals 104. And then we'll divide both sides by 2, and it looks like x is 52. Well, 52 is not negative 4, and it is not 10. So we're in pretty good shape there, but again, we could check this pretty quick. 8 divided by 52 plus 4, 56. Does that equal 6 divided by 52 minus 10, 42? I don't know, I can't, well, 4 over 28, and then 3 over 21, 1/7? Yeah, 1/7. Good. So that checks off, and we could know for sure on the test that that is correct. So I don't know, I get a lot of students that look at this type of problem and, you feel pretty confused because it looks a lot different than the one that we just did. But it's really not too bad because I got 12 plus 10 over x plus 4. We could use the common denominator method to figure this one out. But right here, I just really want to get rid of that 12 by subtracting 12 on both sides. See, then I have just a number, negative 10, on one side of the equal sign, and then I've got 10 over x plus 4 on the other side, which really is a proportion. I mean, if you want to look at that as negative 10 over 1, then we can solve this just like we would any regular proportion, right? So going back to cross multiplication on this, I've got negative 10 times x plus 4, and this should equal 1 times 10. I'm just going to put 10 right there. All right. Now, there's several ways you can proceed from this point. You could divide negative 10 on both sides, which would make that slightly convenient. However, the common method is just to distribute the negative 10. So negative 10x minus 40 equals this blue 10. And continuing to solve, I'm going to add 40 to both sides. And now we'll divide both sides by negative 10 to find that x is negative 5. Now, I don't know, this one shouldn't really be too bad to check. I got 12 plus 10 over, now it's negative 5 plus 4, which is 1. So 10 divided by negative 1 is negative 10. 12 plus negative 10 is 2, and then that checks off. Now, of course, you should show the work, but for time's sake, we don't have it. Now, once again, I mean, if it's helpful, make that 7 over 1 if you feel better about that type of cross multiplication. Others of you, though, may prefer to say, well, I want to get rid of that x minus 3, right? So if I multiply both sides by x minus 3, like this, then my x minus 3's cancel out. That becomes a factor of 1. It's just a different way to look at it. I mean, essentially the approach is the same, though. So now we would have x minus 3 times 7, and this would equal 85. And we can distribute the 7, so 7x minus 21 equals 85. Now add 21. So what do we got, 106 there? equals 7x. Now divide by 7. X equals 1. What was it? Oh, 15. As a decimal, 15.14. It's going to be an ugly decimal. Should be more to it than that. Yeah, sevenths are, I think, 5 decimal or 6 decimal places repeat. I'm okay with the fraction right there. I mean, it didn't say that specifically in the beginning, but I would use it.
So on like a test, you'd be okay.
I'll try to, make it quick. So on this one, I've got 8 times x plus 2, and this should equal 10 times the x minus 5. And distributing, I've got 8x plus 16 equals 10x minus 50. And for me, I'm going to put the x's on the right, just so I don't get any negative x's. And so I'll subtract 8x from both sides and add 50 to both sides. And then finally, divide both sides by 2, and x is 33. And you guys said you checked it, so it's good. All right, so this is the beginning of something very different, but it's also very much the same. Okay, so it's the beginning because, fortunately, on the left side, they've given us 2 fractions, both with common denominators. All right. So, I mean, if we looked at this problem, well, I mean, one thing you could do, right, is you could make this one giant fraction with a common denominator of x plus 3. Then you'd have that 8x minus 35, and then you'd add that 7x as well, and then you'd say this is equal to x. Okay. Or what you could do is you could, well, that's x over 1 right there, right? If you wanted a common denominator, you would multiply that by x plus 3, but as a factor of 1, you've got to multiply that in the numerator as well. So the real question is, which way do you guys want me to proceed? Okay, so we'll use the bottom one, which means I'm going to make that x over 1. And some of you guys won't be surprised by this next step, but I'm going to use cross multiplication. So on one side, I've got x plus 3 times the x, and this should equal the other cross here, which is 8x minus 35. You could have simplified that, by the way, plus 7x times 1. Now the nice thing about multiplying by 1 is it doesn't change anything, right? Now I want to distribute the x into the other set of parentheses, so x squared plus 3x. Now it looks like something that we've been kind of used to in this Module 5 stuff. Well, we can combine those x's. Now seeing this, I mean, I assume we're going to end up with a polynomial. We should assume that there should be 2 answers, because once we make this all one polynomial, we have a degree of 2. So we should expect to see 2 answers on this, right? Okay, well, I want everything on the left, just so I don't get a negative x squared stuff. So what I'm going to do is subtract 15x from both sides, and also add 35 to both sides. And yeah, I did place those there on purpose, so that I'm combining my like terms, right? So I've got now x squared minus 12x plus 35. And now this is where we want it to be 0. Okay, so if it were a linear equation like we had before, without any x squareds or cubes or anything like that, then we would not want it necessarily to equal 0. But in this case, we got 0. All right, so I'm going to look at 35. I need 2 factors of 35 that add up to negative 12. And I'm looking at negative 7 and negative 5. Now, since my coefficient of my x squared is 1, we can split this up right away. Right, we got x minus 7 and x minus 5. This equals 0. So, if I make x minus 7, if it by itself were equal to 0, that would give me an answer. And adding 7 to both sides gives me x is 7. But then we have the other one, x minus 5. if that can be 0 as well, then it would give us a true statement. So x would be, in that case, 5. So we got two answers on this thing. But we need to be careful, right? Just like we had talked about with that first problem. Is in the original expression, we had x plus 3 in the denominator, which means that x cannot equal negative 3. And like I said, we would just want to check to make sure that negative 3 now is not in our answers. It's not, so we're in good shape there, okay? So I got x is 7, x is 5. Again, you'd want to plug that in and check. And I would suggest using a calculator. All right, so on this one, I don't know. Before I subtract that 1, I would need common denominators. But if I can get common denominators, then I can just erase all of them, okay? Specifically, I'm looking at this j minus 3 stuff on the left of the equal sign and j minus 3 on the right. So if I can just get 1 to have a denominator of j minus 3, then we're good, okay? Well, 1 right now is really 1 over 1. So if I multiply it by j minus 3, then I've got to multiply the numerator by j minus 3 as well. And now I have common denominators, which allows me to rewrite the equation without any denominators, because they're all the same. The reason why it's important for them all to be the same is so that we're comparing the same size pieces all the time, okay? It's like if you're going to combine brownies from one pan to the other. If they're all the same size, and you just count how many pieces, combine them, then you know how many pieces of the same size you have. Not that anyone cares. But in any case, this gives us 2 minus 1 times j minus 3, right? I do need that j minus 3 in parentheses there, because I'm subtracting. Because we're going to treat that as a negative 1 right there, right? And then this equals 6. Not too bad. I'll distribute that negative 1 into the parentheses just to show that. Minus j, and now that's plus 3. And I can even combine my like terms right now. 2 and 3, that's going to be 5. So I got negative j, that's a positive 5. And this equals 6. Now I will subtract 5 from both sides. And, well, I can just flip that sign over. So instead of negative j, I've got j, but that becomes a negative 1 right there. And yes, again, you would want to check. So j equals negative 1. Now again, I mean, you should check as well, right? Was there any excluded values from the domain on this one? 3, but it's not part of our solution set anyway, so we're in good shape there. Well, now we're looking at that rational expression stuff like we did the other day. And on this one, I mean, you could cross multiply, right? But cross multiplication is going to require that we get common denominators, which is going to give us common denominators throughout the equation. So that means that I would be able to simply, well, ignore them after I get all common denominators. So I'm going to use that strategy this time. So right here I've got x minus 1. This denominator already has x minus 1. So what is it missing? Looks like an x minus 2, right? But I need it in the numerator as well. So that'll be multiplied by that 6. Here I've got x minus 2, so it is missing an x minus 1. And no, the order does not matter because of the commutative property of multiplication. And this gives me, not in order, but the same denominators for all 3 terms in this equation. So that allows me now to rewrite the entire equation, but without the denominators. So from this point, we'll distribute the 6 into this set of parentheses and the x into that set of parentheses, separately, of course. So I've got 6x minus 12. And then I'm going to add x times x is x squared. X times negative 1 is negative x. And it still equals negative 7x minus 44. I'm going to combine like terms on one side first, and then I'm going to write this in descending order, just so it looks more familiar for us, all right? So to start off, let's combine our like terms. I'm looking at my x's, so I got 6 x's right there minus that 1x. Gives me 5 x's. So I've still got that negative 12. That's a positive 5x. And I've got that x squared as well. So we have a trinomial here with an x squared. So I'm going to want it to equal 0. Right now it doesn't. But I can force it to, right? So now I'm going to add 7x to both sides. I'm going to add 44 to both sides so that I can make this equal to 0. So again, we're combining these with their like terms. So I've got 12 x's, and now this is plus 32. Now we're looking at factoring, general factoring really, because this is a coefficient of x squared that's 1. So I'm going to end up with x here and x there. And we just got to figure out what two factors of 32 add up to 12. There we go. Let's use 4 and 8. So that's positive 4, positive 8. This equals 0. So just going back once again, if I can get x plus 4 to equal 0, then that would give me a true statement. So I got x equals negative 4. But also, if I can make x plus 8 equal 0, that would give me a true statement, so x is negative 8. And that's not interfering with the excluded values in the domain. So that's my two answers right there. Okay, well this is, a little bit different looking. To start out with anyways. When we look at this trinomial here, it's just a regular old-fashioned trinomial stuff. I'm looking at this to factor, okay? So what I want this to end up being is x with plus or minus something, and then another x plus or minus something. I kind of assume it's going to be 2 and plus 2 and minus 7, just because they haven't thrown anything too freaky at us yet. Not that they won't. But I would expect that, okay? Now, so, what are we looking at? Negative 14 here, which splits up. I need the two factors of negative 14 to add up to negative 5. Bam, negative 7 and positive 2. There it is. I'll change the order. Plus 2 and minus 7. Right there. So, when we want the common denominators, now, right, this is just added one step to what would have been the previous problem. So I need common denominators of x plus 2 and x minus 7. So this x plus 2 needs another x minus 7. And then this x minus 7 needs an x plus 2. But also in the numerator, right? Well, now I have common denominators throughout, which means that if I took x minus 7 times x plus 2, I could have had x squared minus 5x minus 14. Which again, still gives me common denominators. So now I've got x minus 7 times 6 plus x times x plus 2. And yeah, we already have experience solving these types of problems from the last example. And hopefully this one now is not too bad. Well, from here, we'll distribute the 6 first. So I got 6x minus 42. And then I'll distribute this x. So I got a positive x squared plus 2x. Now that I got rid of the parentheses, I can combine like terms. So I've got 6 x's with these 2 x's, which gives me 8 x's. Still have the negative 42. That's a positive 8x with my x squared. So now I've written that in descending order. So I've got that x squared, a trinomial. It's in descending order, which is great, but I want it to equal 0, so when I factor, I can find the answer. It's a little bit easier than trying to guess and test at this point. So I'm going to subtract 2x from both sides and add 50 to both sides. Okay, well, again, we got a coefficient of x squared that's 1, so no factoring by grouping here. I just need two factors of 8 that add up to 6. 4 and 2, very good. So I've got x plus 4 and x plus 2. This should equal 0. So if I can get x plus 4 to equal 0. That would be a true statement, so x equals negative 4. But also if I can get x plus 2 to equal 0, that would give me a true statement, so x is negative 2. But we have to be careful, right? Because this is the problem we've been waiting for, right? Is in the original domain exclusions, we saw that x could not equal 7, but also that x cannot equal negative 2, which is shown right here.
Oh, yep.
So I'm going to cross this one out. It's not actually one of the solutions. I've only got one solution in this case, which is negative 4. Again, that's because if I plugged in negative 2 into the original expression, then I would have gotten an undefined value, which we don't want.